Okay, so today we're going to be talking through web scraping, which is super exciting. Basically, the idea of using a web page as HTML to get that information into your Jupyter notebooks and perform whatever analysis you want. Before I get into it, I wanted to highlight some things on the homeroom. I've updated the homeroom for next week. This is what I'll be talking through over the study groups next week. So instead of new material, I'll just be going over some project requirements, some extra things to keep in mind during this project week. So look out for that. And then also just to remind you all in terms of deadline for this project, you are presenting your project on Friday, but it's not necessary to have all of your deliverables done by Friday. Of course, if you want to have the weekend for yourselves, I do recommend Friday, but it's not officially due until the day before you schedule your project review. So not next week, but the week after, from June 14th to 25th. Don't forget to schedule a project review with me. The regular 101 will work. Those like longer time slots that you've seen on my link are for people who are in the part-time program who they have to present their products to me individually. So that was just a note on that. Also kept some of the notes from this week here. Any questions regarding any of that? All right. I saw this on the calendar. Oh, I think that's a few weeks in the future. Okay, never mind. That's like many weeks in the future. There's going to be a project showcase for Flatiron, but that's like, yeah, that's like in a few weeks. So don't worry about that for now. I'll remind you all when that's coming. Cool. Also next week, phase 2 material will be launched. You will get an email telling you to join the, what do you call it? Join the module, I guess. But don't worry about that for now. You get an email and I'll remind you all to do that when that time has come. All right, let's get into web scraping. So the entire section is called HTML, CSS, and web scraping. I will say this first part of HTML and CSS, not a priority, but it does help to understand what it is that you're web scraping. It helps to demystify that like jumbly HTML code, because what we're going to do is, if anyone's ever tried to do the inspect on any browser, I know on Chrome you can just right click and inspect. For other browsers, I forget what the shortcut is, but there is a way to do the same thing. Is to basically demystify this, make this a little bit less intimidating, because for right now it does look like a lot of stuff. So getting through the HTML and CSS lessons, they are actually imported from the software engineering program. So there are a couple like cute activities that you can do there, which are pretty fun. I think you can like put cats in a wagon and color in a rainbow or something like that. So if you want to work through those, not a priority, but you can definitely do that to familiarize yourself more with HTML and CSS. But really all we have to do is be able to figure out where on the page something is, and then just storing that information onto our Jupyters. Okay, so the main important terminology to know here is the DOM, the document object model. The DOM really just provides the interface of our web page. There's more detailed description here, but basically on any web page, and also the web page we're going to scrape as an example is booksscrape.com, which is what we, very similar to the quotes that we had the other day. But basically, this is a website. If I like right click and inspect anything, let me zoom out so we can see more. This basically will represent the entire web page. And the idea of web scraping through this method is we are just going to look for the elements that we want based on their HTML. And we'll walk through that in a little bit. Okay, so the library that we use for web scraping is called BeautifulSoup. There are multiple libraries that are designed for web scraping. BeautifulSoup is one that utilizes the HTML. There are other libraries. If anyone has heard of Selenium, Selenium is another library that you can use. One of the functionalities that actually can control you can write code to control your keyboard and mouse to like hover over a page, and literally like if you want, you can even have them like highlight and copy and paste things. Sometimes if a website's HTML is not as straightforward, you might look to that. Unfortunately, not covered on our curriculum, but there are a lot of good web tutorials online for how to scrape with Selenium. There's also another library called Scrapey or Scrapey. I'm not even sure how that one's pronounced. It's a slightly newer one that actually works pretty similarly to BeautifulSoup, but a couple students in the past have preferred that one over BeautifulSoup, but they work pretty similarly in a sense that you're just parsing through HTML. All right, so the website that we're going to scrape as an example is called Books to Scrape. Let's just imagine we want to build a data set of all of these books. We want to store maybe their title, their rating, their price, whether they're in stock or not. So as an example, we're going to use this website, which is actually built for scraping, so it's a little bit easier to navigate, but I mean, the same principles do apply. And the idea here is we want to get all 1,000 books off of this website. And on this one page, there's only 1 to 20. We'll talk about how we can get all 1,000 in a little bit. Okay. So BeautifulSoup is the library that we're going to use. When I think of scraping, I like to think start big, narrow down. And then I'll start with that first. The things that we're going to import are BeautifulSoup, the library that we scrape with, and then requests. Request was the same library that we had used for APIs yesterday. Very, very similar structure to that. Basically, you do a request.get instead of the URI that we have for the API. We're literally going to pass in a URL. So here we're doing a get request because we're trying to get information. However, instead of doing a .json, because this is not in a JSON file format, we're going to use BeautifulSoup's parser. So there's 2 things here. One, we have the HTML page that we're getting. And actually, let me run this first. If we take a look at the HTML page, I think it'll give us, a response. If I do a .text, similar to what we tried out yesterday, we are literally returned all of the HTML in there. And you can see this is not even very easy to navigate because we have all these like spaces, new line characters, not as visually appealing as this looks. Because this, at least they do the indents a little bit easier to navigate. So usually .text turns the whole thing into a string, so we don't typically use that, but good to just see if it works. So instead of .text, we're just going to throw it through a BeautifulSoup parser. .text, here you can see there's .content. I can show you all what .content looks like. A little bit prettier, but pretty much the same thing. .content also just does that. But what this BeautifulSoup method does is it allows us to parse through this HTML in a way that we can then work with it with very similar to dictionary-like commands. We'll see in a little bit. So all you have to do is through BeautifulSoup's parser, pass in that content, and then also give it a specific parser. There are different parsers that BeautifulSoup has. For the most part, if you're web scraping, HTML is fine. There are a couple websites whose backends are in XML format that looks very similar to HTML. But if you come across something with like XML, there's actually an XML parser as well. But for the most part, most websites have HTML. Cool. So here we can take a look at our soup. And you can already see that it's indented a little bit cleaner, nicer than it was when it was just .text. And we can also do soup.prettify. I don't think this will make a difference because this already looks pretty neat. But if we do soup.prettify, .prettify does have that there. Okay, that didn't really do anything. But anyways, we have our soup here. So within this soup, the 2 main functions that you're going to use to pick out exactly what you want. As an example, you can see that just by scrolling through here, you can find that there are all of these categories. So like books, travel, mystery, historical fiction, sequential art, that if you're familiar enough with the website, you can figure out that that comes from here. Basically, you just want to find the info that you want. And earlier I talked about big to small. By big to small, I mean that for every row, so our ideal data frame here, and I do think that as you're trying to scrape data or call from an API, try and envision what you want your data frame to eventually look like. And in this case, I want every row to be a book, and I want my columns to be maybe like title, rating, price, in stock or not in stock. Maybe I want to save the URL as well so I can navigate to the product page itself. that looks like this. Maybe I want to do that. So that's how I'm envisioning it. Now, when I say big to small, I mean that when you're trying to figure out what to scrape at a particular moment in time, try and capture all of a single item's contents at once. I'll talk a little bit about why you want to do that over looking at specific elements, and I'll go into more detail in a little bit. But basically, the main two methods that we're going to use from BeautifulSoup are find all and also find. And through this process, we will actually get all 1,000 of our books. I'll show you in a little bit. So how does find all work? Find all is when you want to find all results that match a certain search query. So in this case, I'm just searching for this. And how do I know that I want to search for this? Let's just see what this looks like. So this will basically give us a list of something, and I'll go into more detail why that is. You're gonna definitely make use of the inspect tool on whatever browser you're using to figure out what you want to scrape. So I like to right click and inspect. And let's just say, let's focus on the first book for now. So there's this one function that I'm pretty sure all browsers have. This Chrome definitely does, Firefox definitely does as well. That lets you like hover over and figure out, and it'll point you to exactly where in the HTML. As you can see, the HTML on the right side of my screen is being updated, and it's basically highlighting where the info is. So when I say big to small, I mean that let's say I want to get the title. Sure, I can look for this and get the title just directly, but to just keep your code a little bit more consistent, we want to go try and find the entire item. See if there's an HTML element that encompasses all the features of a row as much as possible. So instead of doing this separately from this and this, try and do something that captures the entire object. So in this case, it looks like I want this entire thing here. So do you see how the green was highlighting everything versus something like this, which is only like the price itself, the stars itself. This will help me have everything all together. Cool. So based on that, let me zoom into our HTML code here so we can see a little clearer. Okay, where is that? So that's here. So each item is completely encompassed in this li class call xs6 call all of this. Each item is within this, and we can actually sort of see this website is built pretty consistently. So you can sort of guess that, okay, I'm guessing because there's 20 items on this page, it looks like there's roughly 20 of these. So this makes it actually very easy. If we do a find all on this, we know we're at least grabbing all the information that we want to grab. Now, why go big to small, and why not just get the title itself? Think about the situation where maybe there's missing values. So depending on how a website is set up, this can really, it really depends. Let's just say that one of these books isn't in stock. Therefore, if it isn't in stock, it doesn't have a price. If I were to do a find all on all of the titles, great, I get 20 titles. And if I try and do a find all on the price, I'll have 19 prices. And if I have a list of 20 titles and 19 prices, it's going to be very difficult to match up and figure out which is the one that's missing, unless you manually figure out, okay, the 5th book is the one that doesn't have a price. Unless you're able to do that some way or the other, it's going to be very hard to match up the attributes of each row that you're trying to grab the data for. So that's why you always want to go big to small. And that's something that is very good to keep in mind if you're trying to grab data that is, in a bunch of different parts. So within this li class called xs6, so and so forth, you can actually unnest all of this information, and you can kind of see that all of the information that we want is kind of in here. So I mentioned that I wanted to get the URL. The URL is actually right over here. Now within an HTML, within a DOM, any internal links, I don't know if that's the right word, any link that is within this website is not going to have the full URL. It's just going to assume that, okay, we're going to go bookstoscrape.com/ the rest of this. It just knows by default that you want to navigate within a website. So we have the URL here. Great. We have the star rating. Cool. Let's see what else is in here. Here we have another iteration of the URL. We also have the title. That's great. We have product price, which if we like open this up even more, we're at 51 pounds. It's also in stock. That's great. And I think that's all the things that we want to have for this data. So cool. Everything we want is encompassed within this LI. And how we know it's within this LI, we'll check again when we do the actual scraping code, but everything is indented within the LI. And so we know that all of the information we want is here. So let's get to coding this. The way that find all works, there's actually several ways to run a find all search. This is the way that I found to be the most consistent. You run it on the soup. So the soup, if you remember, is what we had parsed from BeautifulSoup. And then on soup, you can use a find all. And find all takes two arguments. One, what kind of HTML type you're looking for, what kind of, I think it's tag, what type of HTML tag you're looking for. In this case, it's just LI. As you can see here, it starts as LI. And then for HTML, just know that anytime you have within the first set of triangle brackets, anytime you have like something equal to something, this is sort of like an attribute of the HTML. So later we'll see there's a difference between attributes of an HTML and contents of an HTML. Honestly, through trial and error, you can probably figure out which one you need. But in this case, an attribute of this LI class, of this LI, is that its class is this call XS6. So the way that you do this is you just throw this into a dictionary, a key value pair of we're looking for the class that matches this. And you can literally just copy and paste. For Google, it makes it really easy. If you like double click, you can copy and paste. So I copy and pasted that there, and it returns me a bunch of search results. Notice that the data type of my search result is a string. Sorry, not a string, a list. It's a list because it starts with a square bracket. So cool. If it's a list, remember what I like to do with lists, figure out how long that list is, and then also take a look at the first one. So we're going to do both of that. So the length is 20, which cool, sounds good, because there's 20 books on the page, we expect 20, great. Next, let's look at the very first element. And the very first element kind of gives us this more manageable group of HTML. And we know that within each of these elements, all of the info that we have there, even though right now it's not in the format that we want, we know that it's all there. All we have to do is just parse through each of these. And I like to call these mini soups, but mini soup is not a technical term. So I'm going to be calling these mini soups, not technical. So this is for the first one. We can even take a look at some others. Let's maybe look at, I don't know, index 5. Index 5, you can see that for this one, which is the Requiem Red over here, we also have the same information. We have star rating, we have the title over here, price, in stock. We even have, was I looking for the URL? The URL is also here. Cool. So now we know that this is a list of 20 mini soups, each mini soup containing all the information that we want for one future row of data. So cool, let's just save that. So I'm just going to save first 20, which is, I'm going to save this list of 20 to the variable first 20. So cool. And as we did, we can check the length just to make sure it's 20. And just to figure out how it works for one, we're just going to save it to the variable first. So I'm just going to index 0 on first 20. And the first is my first little chunk of HTML that we're going to pick apart to get specifically the information that we want. Okay, so we've talked about find all. Remember that find all, regardless of whether there's one or many results, or even 0, it's always going to return you a list. So if you try like a find all that doesn't work, let me not do it on this one, let's do it on this. If let's say this is not anything, right? If I run this, oops, it's going to return me an empty list. It's still going to be a data type of a list. It's very important to remember that find all returns you a list, because we're going to contrast that with the other method that you're going to use the most, which is find. So find basically finds you the first instance of whatever you're looking for. So to start, usually one of the easier things to find is URLs, because URLs always are an A tag. I honestly don't really know why myself, but URLs are always in an A tag. If anyone's like ever, I don't know, made a blog when you were younger, you might remember like ahref, and ahref is usually always for a URL. So just to do a quick find to just show how this works, we're going to do a find A. Cool. And just like that, we have found the A tag within this mini soup. So now that we have the A, what we want to extract first is this partial URL, which works for now. So, okay, within each A tag, so within the A tag, you can see that this is the open A and this is the close A. The fact that it opens and closes is not a big deal, but within the A open and close triangle bracket, you can see that it says href equal to blah, blah, blah. In a very similar way as for this li, we had a class equal to blah, blah, blah. The href is kind of like an attribute of the A tag. And what I talked about in what I mentioned before, when it's very similar to dictionaries, whenever you want to get the content of an attribute, it works like a dictionary. So if I just want to get this particular string out, I just use it like a dictionary. I call it by its key, and I end up with this URL. So great, I have the URL now. Now I know that all I have to do to get all of the URLs is loop through all the mini soups, and I'll be able to get all the URLs. But let's just look at all of the other columns of data that we're going to use, and then we'll put it all together in a little bit. Okay, so the next thing we're going to look for, let's try looking for the title. So the title, you can see, appears here. This is a version of the title. This is also a version of the title. Let's work on this. As you can see here, it looks like it belongs in an A tag. So let's try a find all to see, because this always catches the first. Let's see if it works on find all. So we can also do find all like this. And then we can see that it is there. Great. Let's also take a look to see whether, oh yeah, good, the title is there. Another way to do it, if you don't want to have to work on like finding all and then taking like the second, taking the second element, another way to do it is try and see what makes this A tag unique from other A tags. So this does take a little bit of getting used to, especially if like it's one of your first few times doing web scraping. You can see that this particular A tag lives within an H3. So a big reason for getting these mini soups and having at least one of these mini soups displayed on your screen is it makes it a little bit easier to digest. And you can sort of see that H3 completely encompasses this A. So here we have the A open, the A close, H3 open and close is right outside of that. So just to make our code perhaps a little bit neater and more consistent, because what if in another book, there are more than 2 A tags versus what we had earlier. So let's try and use this H3. That's actually what I had already. So let's comment this out for now. If I do a find of H3, you can say that straight away, I don't have to like index through the list to get that specific thing out. Quick tangent for web scraping, as long as you can get the result, that is fine. In a lot of websites, there are a lot of inconsistencies. So I only know to use this H3 instead of using a find all on A, because I have, not on this website, but I have on other websites dealt with similar kinds of inconsistencies, where if I always try and do -1, it might not always come out right. So yeah, because of that, let's do our H3. Cool. So within this H3, you sort of see that the title is an attribute of this A tag. So cool, maybe I want to get that title. But because the title is an attribute of the A tag, it's not going to work if I do it on this H3. Because right now it sees that the outermost thing is H3. H3 actually has no attribute. So if I try and do title here, it's going to give me a key error. Very similar to if you're trying to like look up a column or a key in a dictionary and they can't find it. So therefore, we can do this. I think you can also do this. Okay, never mind, you can't do that. But If you know that there's an A tag within this H3 tag, you can actually do another find. You can stack your finds, especially if things are nested within each other. So just like this, I'm finding my A, and then now we're going to see if we can pull out the title. So to pull out the title, because now we're at the A level, we know that title is there. So therefore I can just delete this and pull out title. Cool. Another way that you might be able to do it, I'm not sure if it'll work in this instance. See how the A opens here and closes here. How can I get this information in between? You can do a dot, I want to say dot text. There we go. We can do a dot text to get any information in between the open and close tags like that. In this scenario, didn't really work, probably because maybe the name is too long and what they actually put there is not the full name. I don't know. This is something that you'll have to explore in whatever you're trying to scrape. So we're going to stick with using the attribute. So cool. Now we have URL and we have the title. Next, let's take a look at price. So just by looking, and in this scenario, we don't have too much information per book. Let's figure out what the price is. The price is right over here. So with this, we can just find our P class of, and because there are multiple P classes, we can use the same syntax that we did for our find all to look for the one that's specifically price color. And it looks like there's no other one called price color. So let's just do the same syntax and we get our price over there. And just as I said with this example before, between the open and the close, if I want to get the text, I just do dot text, which I have right over here. Cool. If you want to like strip it such that you don't have that $sign, you can also do that if you want. You can do like one onward, and that will give you the number directly. So up to you whether you want to do that or not. Okay. So we have our URL, our title, and our price now. Just like that, we already have 3 columns of data getting filled out. So let's next look at and see whether something is in stock or not. This one, there's actually multiple ways to go about this. I think I decided to go with the class of in-stock availability, which is in here. So you can see that there's in-stock availability. Let's just see what that yields. In-stock availability looks like this. Cool. You can see that there's also a nested I in there, but I don't think that's super important for now. If we do a dot text on this, we get in stock. Yes, we have all these new line characters, but we can deal with that in a little bit. As long as we can get that as in stock. Maybe we can do like a dot strip, or depending on how we want to store our data in the data frame, you can write like lines of code to clean that up. Okay. Next thing is the hardest one within this. And I will say that this is difficult because of the way that this website decided to name their classes. So we're going to look at star rating. So in this case, the class is star rating 3. This can be problematic because in this case, we know that on this website, different books have different star ratings. So here you can see that there's one that's star rating 3. If I look at another one, let's go down and see, you can see that the class becomes star rating 1. So if we want to write replicable code, this is not going to work. We're going to have to do one separately for 1, 2, 3, 4, 5. I don't even know that if there are half stars. Are there half stars? If they're half stars, it might be different as well. You don't want to have to account for like 1 through 5 and all the possible halves in between. So another way that you can go about this is by using this library called Regex. And Regex is actually a pretty big topic. If anyone is curious about, okay, how do websites and forums validate that your email is in a valid email format? Or how do they guess that your phone number is in a right format, accounting for like, the ones with the parentheses, the ones with the dashes? How do you account for that? Is actually with Regex. For our purposes, because we will get to Regex later in the course, for our purposes, we want to use Regex to figure out how we can just look for anything with star rating. And here what this means, Regex is another language pretty much. These are just going to be wildcard characters. So I'm just going to look for any class that has star rating wildcard. If you're curious about Regex, you can look it up. There are a lot of like tutorials to learn how to do that online. For most things, you don't have to do this. This is actually the only thing that I've ever read web scrape that I needed to use this for. But you can see here that I'm just looking for anything with star rating, wildcard character. So this will actually account for star rating 1, 2, 3, 4, 5, anything that has star rating whatsoever. So when I do this, I have to compile that this is a regex search term. And then we're going to run the find on this class. So when this is done, you can see that I have my star rating 3. And here they have like one icon star thing. And in this case, it doesn't really matter. We don't really need this information. Maybe we just take this star rating 3 for now. So therefore, let's just do the first dot find, pull out the class as well. And we have star rating 3. Now, this was actually really surprising to me, the fact that the class is stored as a list, which cool, makes it even easier for us. So if I know I want to get the number 3 or the string 3, I can do a -1 and also make sure that when I'm running this code on a bunch of different books that it works. So cool, just like that, we have gotten every piece of information we want from a single book. And if the website is consistent enough, this will work for all the books on the website. So let's try and throw it in a function. The way I'm going to store this function for now, or store this data for now, I'm actually going to store it as a dictionary. So in this clean scrape, each of these pieces of code, I actually just copied and pasted from the top. So this function that I wrote is going to take in a mini soup. So I'm going to run this clean scrape function on my list of 20 mini soups, and I'm going to run it in a loop. So I defined it for one single book. So what I decided to do was store the information as a dictionary. You can see that I have storing the title, storing the price. This should look kind of familiar from what we just did earlier. I have the stars. I have the URL. You can see with the stars, I added the -1 at the end so that I can grab the lettered number. And then I have the URL as well. And because I know it's an incomplete URL, I just want to add the front part of the URL just in case. And then in this scenario for the in stock, I just figured that if the substring in stock is in here, that should be good enough because, well, you might run into issues if it's not in stock, but we can always check for that later. So cool. Now that I have this one function working, let's run it and let's test it out. So let's test it out on our first. So clean scrape on first. Cool. So just like that, it takes in a mini soup and it spits out this dictionary of the information that I asked for. My title, my price, in stock or not. And I had it save a Boolean of in stock or not in stock, the star rating and the URL. The star rating, I mean, ideally, I guess you usually would want the number, but that you can do a replace or something. So awesome. I know that this works for one book. Let's try it on all 20. I'm running it in a loop. I'm doing it actually in a list comprehension. So my result is going to be a list of dictionaries. So for book in first 20, do clean scrape of the book. So just like that, I have a list of dictionaries for all 20 books that are on the first page. Cool. And if I wanted to, I can throw this into a data frame. And just like that, I have my 20 books in a data frame, my title, price, whether it's in stock or not, star rating, URL, and then you can just run your pandas cleaning functions. If you want to like, strip out these numbers or figure out the star rating or clean up some titles if you'd like, you can just do that in pandas methods. So cool, we have 20 books just like that in like about half an hour. How can we expand this to all 1,000 books? Now, this is where it does depend on the website. Let's say I scrape this one page. Maybe I want to take a look at the second page. It looks pretty similar. The only thing that will change is instead of using this URL here, I'm going to want to use this URL. And I know it's pretty small, but it says /catalog/page2. So this is page 2. And just to check, is this going to be consistent? If I do page 3, okay, the URL stays the same, just the number changes. Page 4, looks like there's a pattern here that hopefully if the content on the page is consistent with the first page, we can probably run the same function. And the URL seems to be pretty consistent as well. So it goes to 50 pages. Let's see if it works for 50. Page 50. Cool, it worked. And just to try one more thing, let's just see if it works for page 1, because sometimes the page 1 doesn't work. So page 1 also works. Perfect. So now you know that just by changing the URL, very likely I'll be able to scrape every single page. And we're going to use a pagination process, very similar to what we did yesterday for APIs. So before I get to that, what if this isn't consistent? So on most pages, on most websites where you have multiple pages of results, there's usually like a next button that looks like this, right? So if I right click and inspect, one way that you can set up your scrape code is to actually, maybe while scraping all of these books, also scrape the URL that brings you to the next page. And then you can write a function that takes that URL and then runs the scrape on that URL. That makes sense. So you can get the URL that will bring you to the next page. And yeah, that's another way to do it. Okay, so now that we know that this works on all 50 pages, the URL is consistent over all 50 pages, let's write something that can put that together. So down here into pagination, we know that the URL for the first one looks like this, and that worked. The page is exactly the same. If I replace that link that I had at the top with this /catalog/page1, I know that it works because I tried it. So instead of using that, what I can do is actually create a list of URLs. And what I did was I just formatted this string so that it gives me pages 1 through 50. And hopefully all the content on each page is consistent enough for me to use the same methods that I used to scrape for one book and for one entire page. So let's write a function that just works on a single URL first. So on a single URL, I'm going to write a function that takes in the URL, run the request.get, put it in a soup with a parser, and then grab the raw data for the mini soup. So raw is basically the mini soups. And then I'm actually going to use my clean scrape function that I had over here. I'm going to use a clean scrape function that I had over here and loop over that. So this we've actually already done. Now that I've just put this into a function that can work on an entire page all at once. So with this, I know that I can copy and paste my, let's just do a random one. I can take this page's URL, copy it, do get 20 books URL, and that will give me my list of dictionaries. You can also have it return a data frame if you want, really up to you and how you want to set it up. But the way that I have it set up is this works on this URL. How I have it set up is that I'm creating a master list that is going to have 1,000 elements of each element being a book's dictionary, and I'll turn the whole thing into a data frame later. I'm doing this because data frames are actually pretty memory intensive. It's actually storing a lot of additional attributes, whereas dictionaries don't store as much, I guess, metadata, you can say. For your projects throughout this program, not going to really matter, but good to keep in mind that it's actually more efficient to store things as lists and dictionaries versus data frames. Because if you think about data frames, they're, the fact that you can like kind of interact with it, and the fact that they're storing a lot of attributes, data frames can get very memory intensive. So cool, let's just do this. I'm making an empty list of all dictionaries, and I'm extending this list with the result of get 20 books. And let's just take a look and see. Might take a while because it's going to run through 1,000 books, but we're using extend, remember, instead of append, because if I did append, I will actually end up with, I think, 50 elements, and then there's going to be like nested of 20 books for each element. that doesn't make sense, go and try it yourselves. But here you can see just like that, I have 1,000 elements in all dictionaries, and then I have all of my books data all in one place. And with that, I can turn that final thing into a data frame. And just like that, I have 1,000 books. Cool. So that's really quick overview of web scraping. Any questions before I want to talk about one more web scraping thing, then we can close out. Okay, I want to show you all a more fun way to, not more fun, but sometimes easier way to web scrape. So let's do an example. Let's see what's in here. I'm just going to go to a random Wikipedia page. Let's see, what's a good one? Wow, I don't know, maybe Western Europe. Okay, so let's say I want to scrape this table. And let's say all I want to do is take this table and have it as a Pandas data frame. I'll tell you now that scraping tables using HTML is actually very difficult. If I right click and inspect, anytime you see a table class, that should signal that you should not use BeautifulSoup or HTML. I know this through my own experience and a lot of other students' experiences. Scraping a table is very, very difficult because you actually have to deal with like the rows and the columns separately, and there's just a lot going on. I want to show you all a simpler tool. So as long as you see table and what you want to scrape is in the table format, I will introduce to you all Pandas, a Pandas function that's super helpful. So in Pandas, there is a function called read HTML, and it actually takes in a URL. Oops, did that not work? Ah, okay, hold on, give me a sec. Hit install. This is because I decided to like reinstall all of my things on my computer and I missed a bunch of libraries. Okay, hopefully this works now. Please don't be LXML. Okay, I'm gonna just restart this kernel really quick and then relaunch it because I do want to show you all this really neat thing. Okay. Yeah, I'm gonna close this first and then relaunch it. Just bear with me for a little bit. Okay, let's see. With our pandas, import pandas as PD. And then if this doesn't work, I'll just describe it to you all. Here we go. Great. So what Pandas read HTML does is it actually returns you a list of data frames, which is super interesting. What it does is it's going to parse a page and look for every table that exists on the page and turn those tables directly into data frames. It'll make your life a lot easier, especially if you're trying to scrape a table. So let's just explore this result. So Wiki Tables. So here we have Wiki Tables. Let's look at see how many we have first. So we have 27 tables. Okay. And let's look at the first one. So that doesn't look relevant. There's going to be a little bit of noise in here, but sometimes if you know that like, oh, that's also messy. Let's maybe look for a nice one. Okay, here, regions of Asia. So here you can see that it already puts into a data frame. This example is not the cleanest, but I have also done examples where it's a lot easier as well. Anyways, I'm not gonna like spend the time, maybe a couple more. But anyways, if you find table objects on a website, I know like those like sports statistics websites, they work really well with read HTML because they have a lot of like tables of like, I don't know, sports statistics. Those work really well with read HTML, much better than if you try and manually scrape it with BeautifulSoup. So always remember, if something is super hard, probably there's something built to make your life easier. And read HTML, if you want to scrape tables specifically, is one of those things. But yeah, that's all I had to share for web scraping. Again, very optional for this project. But I think one of the websites that I think is the numbers. Yeah, this website works pretty well with web scraping. If you want to look at, I don't know, an annual box office, this data actually scrapes pretty easily. So if anyone's interested in doing that, I know that our data from the numbers is the one that's TN. That one's a little bit outdated. So if you want to try your hand, it doesn't matter if it's outdated for this project, but yeah, if you want to use up-to-date data, you can do this here. Cool. Any questions regarding web scraping before I stop this recording? Going once, going twice. All right.